Welcome to The Explainer. Today we are diving into some pretty fascinating new research that uncovers a surprising connection between alcohol, inflammation in the brain, and our cognitive health down the road. So let's start with something we've known for a while. A massive French study, and I mean massive, it looked at over 31 million people, found that alcohol use disorder was linked to a 3 times increased risk for dementia. 3 times. That's a huge number. So we know there's a really strong connection there. But the why of it all, that's been a total black box, a real biological puzzle. But now, some new research is finally starting to fit the pieces together. Okay, so a recent study out of Washington University decided to really dig into this link. They looked at a group of older adults who all had a lifetime history of what's called alcohol use disorder, or AUD. And no big surprise here, they confirmed what lots of other studies have found. The participants with that history of AUD had much higher rates of cognitive decline. Their scores were about 1.3 times higher on this specific scale. So the link is definitely there. It's solid. So the obvious next question is, right, is the alcohol just speeding up the classic signs of Alzheimer's disease? You know, the buildup of those amyloid plaques and tau tangles that we always hear about? But this is where things get really weird. When they actually measured the blood biomarkers for Alzheimer's, they found no real difference between the groups. And that created this huge puzzle. If it's not the usual suspects, what on earth is actually causing the damage? Now, to solve this puzzle, a second team of researchers started looking at a totally different culprit, neuroinflammation. And here's the key. They didn't start by looking at older adults. They went back decades earlier, all the way to adolescents. For this study, they focused on post-mortem brain tissue from people with AUD. And get this, the average age they started drinking was just 17 years old. And their analysis was just striking. Basically, the earlier a person started drinking heavily, the more signs of brain inflammation and actual neuron damage they found when they looked at their brain in adulthood. This is a huge clue, right? It suggests this whole damaging process might get kicked off way, way earlier than we ever thought. This finding pointed them toward a very specific inflammatory pathway. You can think of it like the brain's own emergency fire alarm system. It all centers on this one protein called HMGB1. Now, normally, it just kind of hangs out inside the cell's nucleus, doing its thing. But when a cell gets stressed out from something like binge drinking, it gets shot out of the nucleus. And that's the signal. It basically yells at the brain's immune system, hey, we've got a problem over here. And check this out. This isn't just some theory from an animal model. When the researchers looked at actual human brain tissue, they found that people with AUD had almost double, 1.9 times the gene expression for this HMGB1 alarm bell. That is a massive difference. So you can start to see how this creates this really vicious, long-term cycle. It starts with binge drinking, when the brain is still really vulnerable and developing. That triggers the HMGB1 alarm. That alarm then turns on this chronic inflammation. And that fire just keeps smoldering, slowly damaging these critical neurons that we rely on for memory and thinking. So, discovering a specific mechanism like this immediately brings up a huge question. If we know what's pulling the fire alarm, can we stop it? Could we maybe even reverse the damage that's been done? So to test this idea, they turned to an animal model. They exposed adolescent mice to alcohol, and then they gave them a compound that actually comes from licorice root, of all things, which is known to block that HMGB1 signal. And the results were, well, they were pretty remarkable. In the mice that got this inhibitor, the signs of chronic brain inflammation just plummeted right back down to almost normal levels. It's like they were able to put the fire out. But here's the really incredible part. It wasn't just about stopping the inflammation. The treatment actually rescued the memory neurons. The mice that were treated with the inhibitor didn't show that alcohol-induced neuron loss. It's like their brains had actually recovered. That's huge. So what's the big takeaway from all of this? Well, this research is telling us a whole new story. Heavy drinking, especially during those adolescent years, can light this inflammatory fire in the brain that just keeps smoldering for decades. And this inflammation itself, driven by that HMGB1 protein, could be a primary cause of cognitive damage, completely separate from the classic Alzheimer's plaques. And most importantly, it shows us that alcohol's effect is a modifiable risk, and it points to a brand new target for potential therapies. It completely shifts the conversation, doesn't it? We're moving away from this idea of just irreversible damage and toward thinking about this as a dynamic process we might one day be able to interrupt. And that leaves us with a really powerful and even hopeful question to consider for the future.